Hi, I'm Shadi Sayde. I'm assistant professor in bio and ag engineering, and I'm here today to talk a little bit about our new technologies that we are working on. Actually, we are developing a device that allows us to measure sediment erosion from around bridge foundation and critical infrastructure. Not only measuring the erosion process, but also we are measuring the environmental factor that's causing erosion, such as velocity profile in the river, in the stream, as well as water depths. So why it is important to monitor erosion, what we call also a scour. In fact, scour is the main reason for bridge failure across the U.S. And we estimated that in each year we have around 22 bridge failing because of scouring event that's happening around the foundation. So this device is designed to mitigate the issues that we're observing with other monitoring devices, such as the high resolution monitoring. We need a very high resolution devices to look at the progress of the location of the sand-water interface, for instance. We need low-cost devices in terms of maintenance and installation, as well a device that will allow us to measure, to monitor scour during large events. And we designed the device was having those limitations in hand. So, for instance, our device allows us to measure the erosion at very, very fine resolution. We install it around bridge foundation, and we can look at erosion at sub-centimeter scale. And we can do that every 5 minutes at very high resolution. We can also, as I mentioned before, we can monitor the thermal profile along the device, as well as the water velocity if we decided to do so, and the water depths. And so far we tested in the lab, as well we tested in the field. We deployed a couple of devices and around bridge foundation in the field in dynamic river condition, and the results are very strong so far. It's very consistent with the lab testing. But we still need to move it to the next level, to the market-ready devices. And mainly what we need to do is to create the cyber infrastructure around this device. We needed to have it as an early warning system that allow us to transmit this information to the end user, telling them, hey, there is an issue with your bridge. We need to intervene at this particular moment. And for that, we need to develop the infrastructure around it, such as Wi-Fi connectivity, connecting to the cloud computing to get the real-time data. As well, we need to improve the design to test it under different river conditions, such as if we have gravel system or we have more a sandy system, or testing under extreme condition for a longer period of time. But in principle, the prototype demonstrated that it's working, and what's the next step is just bring it to the market level.